All right, so section 3.2 is using properties of parallel lines. So if two parallel lines are cut by a transversal, then theorem 3.1 states that corresponding angles theorem, that pairs of corresponding angles are congruent. Now remember, corresponding angles are F angles. So we can look at this here. And if I go right here, here's my F. We see that 1 and 5 are corresponding angles. And again, by the same pattern, we should see that 3 and 7 are also corresponding angles. So we can say then that angle 1 is congruent to angle 5, angle 3 is congruent to angle 7. And again, if we go the other way, again, if we go this way here, we should see that 2 and 6 and 4 and 8 are congruent. That's when they're parallel. And remember, parallel we can tell by the little arrows there. So that little arrow there and that little arrow there, or they will let us know. All right, so again, we can say that angle 2 is congruent to angle 6, and angle 4 is congruent to angle 8. Okay, theorem 3.2 states again, if two parallel lines, so again, this whole thing follows all of those. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Remember, alternate interior angles are Z angles, and they're on the inside, so 3 and 6, and 4 and 5. All right? So I just say angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Same thing with the alternate exterior angles. So if we look at the alternate exterior angles, again, we're going to have 1 and 8, and we're going to have 2 and 7. Okay? 1 and 8 and 2 and 7. So I can say angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Okay, so then theorem 3.4 states that consecutive interior angles theorem. So remember, when they're on the inside of the thing, so on the inside, so 3 and 5 are consecutive interior angles, and 4 and 6 are consecutive interior angles. And what that states is that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So what that is telling us is that angle 3 and angle 5 are supplementary. And angle 4 and angle 6 are supplementary. And remember, what does supplementary mean? It means that their measure, so i.e. the measure of angle 3 plus the measure of angle 5 is equal to 180. Same thing with angle 4 and angle 6. Okay, since they're supplementary, their measures equal 180. All right, example 1. The measure of angle 3 of the numbered angles are 75 degrees. Identify the angles and explain your reasoning. So again, we're looking at all the ones that are the measures of 3 of the numbered angles are 75 degrees. So it's asking us which ones are 75 degrees. So if we remember, here's the easiest one right here, vertical angles are equal in measure. So we can say that the measure of angle 2 is equal to 75 degrees. Again, we just said vertical angles are congruent. Okay, and let's see. So I'll go ahead and put 75 there so you know. And let's see here. Oh, let's see. I believe, again, kind of look at stuff that we just talked about. All right, so if we think about it, angle 6 is equal to 75 degrees. Again, what did I just draw there, people? I drew a Z and their alternate interior angles. So we can say alternate interior angles are congruent. And then if you want to think about that, so let's erase that and put a 75 there also. And then if you think about it here, you would say angle 6 and angle 7 are also vertical angles, so you could use that. But let's go ahead and just to get you to think about the other ones here. So 75 degrees is right here. Again, look at what I have here. I have F angles. What are F angles again? Corresponding angles. So we can say that the measure of angle 7 is also equal to 75 degrees because corresponding angles are congruent. Okay? So again, I'll erase all that. And we can say this one here was also 75. So again, either by vertical angles or corresponding. Okay? Or if you want to think about it, you could have even said alternate exterior angles because you know that angle 2 was 75 degrees. So notice we had a lot of ways that we could get that one done. Example 2, find the value of x. All right, so let's see here. We know that this is 2x here, right? Because there's z angles, we would also know that this one here is also 2x, all right? Since that is 2x, you would also be able to tell me that these two here form a linear pair. Remember, a linear pair means that they are equal to 180 degrees. All right, so we can say that 2x plus 120 is equal to 180 degrees. All right, because again, what we do? We use the z angle, so since 2x is a alternate interior angle, right? And 2x and 120 form a linear pair. So we can say then that 2x, again, we're going to subtract 120, is equal to 60, and then we're going to divide by 2. So we'll get that x is equal to 30, and that's what they asked us to do, find the value of x. All right? So hopefully you saw that there. Okay, example 3. Find the value of y. So if we're going to look here for the value of y, again, let's kind of look and see if you can see a pattern here. On this one here, they're on the exterior, and they are alternate exterior angles. Again, that's your transversal. So remember, alternate exterior angles are congruent. So we can say So we can say then that 6y minus 3 is equal to 129 degrees. I'll add 3 to both sides. I'll give me that 6y is equal to 132. And now I'm going to divide by 6. And when I divide by 6, I'll find that y is equal to 22 degrees. All right. Oh, look. Now we have a proof here. There's no proofs on the homework, but again, ladies and gentlemen, I think it's important that we at least understand that we do have some stuff here that we might not show you, but it is still important to learn. All right. Because you never know when you'll see a proof. So I'm going to do a quick one here for you. And we're going to call this statements and reasons. All right. And I'm just going to kind of lead you through this one. So remember, I told you always, the first reason is always going to be given. So we have P is parallel to Q. And our reason is given. All right. Now I want you to kind of think of a plan here. So they want us to show that angle 1 and angle 2 are supplementary. All right. So we're trying to prove, that they are C angles, and which we know are supplementary. But again, we know that these two are parallel. So you have to kind of look at other things here. All right. And since we're trying to prove 1 and 2, we're probably going to have to use angle 3. So what did I just draw there? I just drew a Z angle, which again is alternate interior angles because they're on the inside. All right. So we're going to say for our second one here, because we were given that the lines were parallel, we can say that angle 1 is congruent to angle 3. And our reason, notice how I'm putting a 2 on each side. Our reason is alternate interior angles. Are congruent. All right. Then for number 3, okay, since they're congruent, what else do we know? If the angles are congruent, we know then their measures are equal. So I can now say that the measure of angle 1 is equal to the measure of angle 3. All right, again, because I was told I could tell that they were congruent, so I can tell that their angles are measured. Again, why is that? Because we know that the definition of congruent angles. Okay, definition of congruent angles tells us if we know they're congruent, then we know that their measures are equal. So again, notice how I'm using the one from above to help me with the other one. Okay. Now, we don't really know much more, but again, if we look right here, you can tell me that angle 2 and angle 3 are a linear pair. And what do we know about linear pairs? We know that they equal 180 degrees. And again, that's from one of our postulates that we learned earlier. All right. So we can say then that the measure of angle 2, plus the measure of angle 3 is equal to 180 degrees. And again, our reason is by the linear pair postulate. All right, so now I want you to kind of see. I have the measure of angle 1 equals the measure of angle 3. I have the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So can I not substitute angle 1 in for angle 3? Because we said they were equal. And what was that word I just told you? Substitute. So we're going to say then that the measure of angle 2 plus the measure of angle 1 is equal to 180 degrees. And again, I just told you by substitution. All right, and now notice that we have the measure of angle 1 and the measure of angle 2 are equal to 180. So if they are equal to 180, we know that they are supplementary. So we can now say that angle 1 and angle 2 are supplementary. And our reason for that, I just said the word are supplementary, right? And remember, I told you if we hear the word is or are, a good enough reason to think is by definition of, in this case, supplementary angles. And we are done. All right, and our last example here, a balloonist sees a car at a 37-degree angle of depression from the horizontal. In the diagram, the measure of angle 1 is equal to 37 degrees. What is the measure of angle 2 and how do you know? So the angle of depression, what that means is depression means down. All right. So if we think about this now, they're telling us that this line here, which they have an arrow on, and this one right here are parallel. So again, when something is parallel, what do we look for? We look for Z, C, or F angles. Can you see one there? All right, so I just drew a Z angle there. And remember, those are alternate interior angles because they're both on the inside of the parallel lines there. So you would be able to tell me on this one here that the measure of angle 2 is equal to 37 degrees. And your reason would be because alternate interior angles are congruent. All right, so we talked about the angle of depression. The other one you'll see is the angle of elevation. That would be mean when you're looking up. All right, so you might have one eventually that says the angle of elevation. All right, that's it, people. You should be able to do this homework. Thank you.